Hello everyone, my name is Siddesh and I'll be representing Group 10. In this presentation, I will be discussing our project on loan approval prediction using machine learning models. Specifically, we will look into three models, which is ElasticNet, Random Forest, and Neural Network, and how they perform in predicting loan approval status. The loan approval process is crucial in the financial sector as it determines whether individual or businesses have access to credit. Due to the growing need for a quick decision and increase in available data, machine learning has emerged as a key tool to automate this process. In our project, we aim to predict loan approval status using machine learning models. For this study, we have combined and normalized three publicly available loan datasets to create a more representative dataset for our analysis. These features include current loan amount, credit score, annual income, monthly debt, loan term, and home ownership. So these are the three publicly available datasets. Further, we will be dividing our data into training and testing, which is 20 for testing and remaining for training. So this will print the data set. This will print the column names of the data set. This will print the data type of the columns of the data set. This will give the further info on the data set. Further, we have also handled the null values and we have cleaned the data set with the help of finding the median and the mode. We have handled the null values, finding the median and the mode. Okay, so this is the script which will perform an initial exploratory data analysis on multiple data sets, providing essential insights into their structures. It checks for the number of rows and columns, identifies the missing values, and reports on each column's data type, number of unique values, and missing values. The function is applied to several data sets stored in a dictionary, offering a quick overview of the data before further analysis or pre-processing. This step helps to ensure that the data is clean and well structured for subsequent modeling and processes. Further, the series of tasks are performed to prepare and clean the loan dataset for further analysis and modeling. So this is categorical data handling. It identifies the categorical columns in the data set and prints the value count for each categorical variable. Value count for each variable. Further, feature selection and data preparation has been done. It like renames and selects important features across different data sets and applies mapping to standardize the loan status values into binary. Feature encoding is also been done, like categorical variables are encoded using label encoder to convert them into numerical values. After cleaning and pre-processing the individual data sets, they are merged into one final data set, which is merged underscore PDF, which is saved to the CSV file for further use. This is the merged DF. Further, we have done the visualization of the data set. Like we have plotted the pie charts, the bar graphs, multiple scatter plots. We have also mentioned the outliers in the data set. We have also mentioned the heat map, which shows the correlation of the features. This is our final data set, which we will be using for in the models. So I'll head to my model, which is neural network. So first we'll be importing all of the important necessary libraries. First, we will like remove the missing values and filter out the extreme outliers, such as loan amount, current loan amount, which would be greater than 10 million. Categorical variables such as term and home ownership were label encoded into numerical values. Features were like normalized using standard scalar to ensure like all variables are on the same scale. We have also used SMOTE, which is synthetic minority oversampling technique, to address class imbalance in the training set. This technique generates synthetic data points for minority class, improving model performance. Moving to the model architecture, the neural network consists of two hidden layers, which is 32 neurons each and ReLU activation function. Regularization was also used, like for first it is 50% and then it is 30%, which was applied to reduce the overfitting. The output layer uses sigmoid activation function for binary classification. I've also used the optimizer Adam, which has learning rate by default of 0.001. Training and evaluation, like for the model was trained for 15 epochs and batch size was set to 32. The model was evaluated using accuracy, precision, recall, and F1 score. And also the confusion metric and ROC curve were used for deeper analysis of the model performance. As you can see, we have used 15 epochs. So as we can see, the accuracy of the model is 93.9%. The model was able to correctly predict loan approval status 93.5% of the time. The precision was 94.38%. For the approved loans, the model correctly identified 94.38% of the time of them. Recall was 97.18%. So the model identified all 97.18% of the approved loans with a very low false negative rate. F1 score was 96%. This balanced the trade-off between the precision and the recall, indicating a strong overall performance. The ROC curve and the AUC curve of 0.972 further validated the model's excellent ability to distinguish between the approved and rejected loans. I've also plotted the confusion matrix. I've also plotted model accuracy over epochs and model loss over epochs. So at the end, this chart will compare the performance of all the three models, ElasticNet, Random Forest, and Neural Network across all four key metrics. As we can see, like Random Forest and Neural Network consistently outperforms ElasticNet, especially in the recall and F1 score. Overall, the neural network shows the most balanced and highest performance across all of the metrics. That's it from my side. Thank you.